Okay, so moving on, how do you take this midpoint concept of one line and use it for a triangle? So let's say we have a triangle that looks like this. 2, 3, 4, 5, 6. Well, let's just give these some numbers. Let's just call this 0. I'm talking about the x-axis here. And let's call this 1, 2, 3, 4, 5, 6. And in the y direction, here's the y. Let's call this 1, 2, 3, 4. Okay, so now we can just eyeball this, right? Using this formula, if we take, let's just go ahead and do it. X is going to be the average of 0 and 6. So x is going to be over here, 6 plus 0 divided by 2. That is the same as 6 divided by 2 equals 3. 1, 2, 3. We could have just eyeballed that, but hey, what the heck. This is going to be 0 here and 4 up here, if this is the 0 line. So doing this one, and this is the x direction. In the y direction, it is 0 plus 4 divided by 2. The average of that is 4 divided by 2 equals 2. There it is. Now, what we're really trying to figure out here is what's the midpoint of this line. Okay, and if you take this dotted line up and see where it intersects, and this dotted line over, and you see where it intersects, the intersection of those two is the midpoint of that line. Now let's just go ahead and lay over this. Should have left a little more room here. Let's just go ahead and put the y-axis in here. So now we have the x and the y. So where is that midpoint? Well, that midpoint is over 3 and up 2. But in order to locate this midpoint, you can't just say a number because it's over and up. So in this case, the midpoint is a combination of the midpoint of the x, which is 3, and the midpoint of the y, which is 2. So in this case, the midpoint of the line at an angle in a triangle has to have two terms. It has to have the x and the y. And so for us, it is the x is the 3 and the y is the 2. So that midpoint is now represented by an ordered pair, 3, 2. So now we're going to take this one step further. Now we're going to do the midpoint of a triangle where all that we are given are the coordinates. And this is the challenge part. So here we go. Let's just go ahead and make ourselves a graph. And let's draw a triangle on here. Well, let's just pick one. How about this one, and this one? And let's just name these corners. Let's just call it corner A. I don't want to use A because we already used that for the distance. Let's just call this corner R, corner S, and corner T. And let's give each of these corners a pair. So R is going to be a numbered pair. It's 2, 2, 6. S is going to be 2, 1 over 2 up 1, and T is going to be 1, 2, 3, 4, 5, 6, 7, 8, and 1 up and okay. So now what you're going to have to do is imagine the triangle that is formed here. And there's no formula that tells you this distance. So what you're going to have to do is find the midpoint of ST, somewhere in here, and draw it up. And you're going to find the midpoint of RS and draw it up. So really what you're doing is you're just doing two separate problems. You're finding the midpoint of this and the midpoint of that. Roughly, it's going to be there. So how do you find the midpoint of that? Well, it's going to look like this. It's going to be the average of this distance, so S T. What is the distance of X S T? Well, you could do it a number of different ways. You can say in the X direction only, point S is 2, 1. Point T is 8, 1. So what is the horizontal length? Well, the Y direction is the same. They're both 1 up. So the difference is 8 plus 2 divided by 10 is the average of the 8, the average of the 10. So the midpoint of ST equals 2 plus 8 divided by 2 is the average. That is 10 divided by 2. That is 5. And let's see if 5 works. 1, 2, 3, 4, 5. Look at that, it works, because there's 3 over here and 3 over there. So the midpoint is 5 over here. So then how about over here? What is the midpoint of RS? Okay, well, RS is going to be a combination of 2, 6, which is this one, and S, which is 2, 1. Okay, here's the R, here's the S. Now, the 2 remains the same. So actually all we need to do is find the diffs. They're both 2 off here. What we need to find is the Y difference, and we need to find the average of this and that. So in this case we're only looking at the Y's because the X's are the same. So the midpoint of RS is going to equal the average of, we'll call it 1 plus 6 divided by 2. What is that? Well, that's 7 divided by 2. That is 3.5. So now the midpoint of RS is at 3.5. 1, 2, 3.5. There we go. Does that work? Because we have 1, 2.5 on this side, 1, 2.5 on this side. Okay, so what we just did was this is the midpoint in the X direction. This is the midpoint in the Y direction. And if we go over from here, over 3, and we go up 2.5, it is going to put us exactly there. This is the concept. However, what this does is it tells you the midpoint relative to the triangle, okay? But what we actually want is the coordinate location of the midpoint. This gives you the idea of what this is doing, but now we've done this, I'm going to ask you to please ignore that. This is trying to get you to understand how this works. But now we're going to have to do it relative to the entire coordinate plane. That's another story. So for the coordinate plane, we're going to use this formula. It looks like this. For the midpoint of any line, we are going to say there's, for any point there's an X and a Y, and an X and a Y, and you're going to take the average of the X's, the average of the Y's, and that's going to give you the average of the X's and the averages of the Y's, and that's going to give you the X average and the Y average.